Good evening. A very happy new year and welcome to The Sky at Night on BBC4. I may say this is a special time. Not only is it our first programme of 2007, it's also our 650th Sky at Night, which is quite a record, I think. And today we have a very special guest, Piers Sellers, the British-born astronaut. First of all, though, our news notes. Chris, good evening. For our first news note, we've got to come back to Mars. Mars Global Surveyor had a long and honourable career. We have lost touch now, unfortunately. They sent back some amazing pictures, particularly of new impact craters.
That's right, it's nice to see changes on the Martian surface, and because Global Surveyor was in orbit for almost 10 years, we can actually see things happening. Look at this region, it's perfectly calm in this image from 1997, and we look at it now, and there's an impact crater.
Right.
And in fact, it's discovered more than 20 recent impacts, and they tell us about how often Mars is being hit, which is very important when we come to date bits of the surface by counting impact craters.
And there are impact craters also under the smooth northern plain, so this really is a shock.
That's right, this is a result from MARSIS, which is Mars Express,
Yes.
the European spacecraft's radar instrument. So if you look at a globe like this, it's obvious that there's something different between the north and the south hemispheres
The
of Mars.
rough cratered south and the smooth north.
Exactly, and the traditional interpretation is that there's been lots of stuff happening in the south, lots of time for craters to hit it, and so this is old,
Right.
and the north we thought was young.
Quite.
But with MARSIS, we can look beneath the surface of these smooth plains, and we see impact craters underneath. And what that tells us is the underlying crust is old, and yet it must have been covered.
That's fascinating, but to me the most exciting thing of all is the discovery of what I believe to be water streams within the last few years.
So this is back to Global Surveyor, and we knew there were channels on the surface. We've seen those pretty much since spacecraft have started looking on Mars, but now we see changes in them. We see bright deposits being left sometime in the last decade as something flowed down these channels. Now the question is, what flowed?
I think myself water. There must be a lot of liquid water under Mars. You can have springs and water coming down these channels.
Yes, it can't last for very long on the surface. It would boil off almost instantly, but maybe there's enough time to just carve out these channels. Personally, I think we need to do a lot more work.
I think myself is water. And somebody said if you were there and saw this torrent coming towards you, you'd want to get out of the way.
You certainly would. I hope you take a photo on the way.
I certainly agree. So Mars is still a mysterious world. Much further out, let's turn now to Saturn, or its main satellite, Titan. A world bigger than the Moon, with a dense atmosphere. And there we now see mountains.
That's right, we're in the middle of a series of passes by the Cassini probe near to Titan, and they've got very good at tuning the wavelengths they choose to look in to penetrate that dense orange atmosphere and see features on the surface. And as you say, the most recent are a set of mountains, the ridges running from top to bottom in these images. And these mountains are something like a mile high. They're really very large features, and they may be evidence that tectonic activity has happened on Titan sometime in the past.
I'm sure it has. Also, there are lakes there, but not lakes of water.
That's right. And we're beginning to see a whole, not a water system, but the way that the chemicals in Titan's atmosphere and on the surface interact. Look at the mountains again. They have a deposit, a bright deposit on their peaks, essentially. Now, this could be snow, could be material falling out of the atmosphere onto the top of the mountain. So we may be beginning to see what the effects of weather on Titan as well. It's a fascinating world.
It is indeed, and Cassini, of course, is still operating.
It is. There's another Titan flyby coming up very shortly, so there's plenty more.
Let's turn now to the wanderers of the solar system, the comets. And our Stardust probe has visited Comet Wilk 2 and has brought back samples. And they contain some very surprising information.
Absolutely. For one thing, a large proportion of the material in the comet appears to have formed in warm temperatures, which means the inner solar system, and somehow been transferred out into the cold outer regions of the solar system. Now, we've got a rough idea of how that might happen, involving jets from the newly formed star, but the details aren't at all known, and this was unexpected. Look at the chemistry of this thing as well. We've seen some very complicated chemicals, things like methylamine or ethylamine as well. And they're much further along the road to producing the chemicals associated with life than we expected to find in what is, after all, a relic of the early solar system. And it may just be that the building blocks for life are in place even before you form the planets. And that's a really important result.
And now let's go beyond the solar system. And this is your province, Chris.
Yes, there's just one pretty picture which I thought worth mentioning this month, and this is a supernova remnant left over from the explosion of a dying star in the Large Magellanic Cloud.
170,000 light years away.
That's right, and it combines two sorts of information. It shows X-rays from Chandra, which are shown in blue, and infrared light from Spitzer in red. And what we can see is this expanding shell of material interacting with its surroundings. The complicated shape and the bright portion down at the bottom of the image shows where this expanding shell from the supernova is bashing into the interstellar medium, and we can see the interaction between the two. And this sort of process might just trigger another wave of star formation.
Chris, thank you very much. And now for our very special guest. Piers Sellers, British-born astronaut who's been up in the International Space Station. And a few days ago, he came to see me. I began by asking him how old he was when he first decided to become a spaceman.
When I was about 7 years old, Patrick.
So did I, but you made it, I didn't.
Yeah, my dad explained to me about the Yuri Gagarin flight, how this man was flying around the world so fast. He saw a day and a night in an hour and a half.
I remember telling me that.
That excited me. I thought that was extraordinary that anybody could travel so fast and see something like that, and it just entranced me. And then I watched the lunar landings, helped by you and James, and that was tremendously exciting. I watched the whole business of the Apollo program and the landings on each landing on the moon, and I never lost the thrill. Always wanted to do it, and got lucky enough.
First of all, one of the standard questions: what the Earth look like from space?
It's extraordinary. It's blue, white, and it's so bright that it looks like it's glowing. It looks like it's neon. You can see the curvature of the Earth from horizon to horizon this way, but what's surprising is you can actually see the curvature going away from you, over the horizon like that. So it really does look like a ball tumbling through space.
The second standard question: what about zero gravity?
Zero gravity is immense fun. You would absolutely love it. It's like flying. It's a little annoying sometimes because you keep losing stuff. If you put anything down, it tends to float away.
What's it like living on the space station?
It's great. Inside, it's really huge. If you could imagine a 747 aeroplane and you take all the seats out, that's about as big as it is inside. And it's like that. It's a long tube made up of an American segment at the front and the Russian segment at the back. The American segment is all white and black. It looks like a workplace, which is what it is. It's a laboratory and an airlock. And then when you get back to the Russian segment, that's the living quarters. It's more homely looking. We have pastel colors on the walls, and there's the galley down there and the sleeping quarters. So we have an office and we have a home base on the space station.
How many are on the space station with you?
Space station has a crew right now of 3 people. And when we visit on shuttle, you know, obviously we bulge up to 9 or 10 people, depending. But starting in 2009, the crew of space station will go up to 6. And there will always be a couple of Americans, a couple of Russians, and then we have Japanese and European astronauts.
As you so rightly say, one of the most important points about it is international.
That's right. It's a human enterprise.
Yes.
I think this is man as the species pushing out into space rather than a single nationality. And that's good.
Well, you said that zero gravity is rather fun. How long were you in space? How long were you in space consecutively?
11 days the first time, 13 days the second time. And that's after, it takes a day or two to get used to it, to your body to settle down, to being in orbit. The first day your back hurts because in 0G your back stretches out about an inch. And that really hurts. But you take some aspirin and that dies down. And after a day that settles down. And you can feel your stomach rise up a little bit. It's a bit like being in an elevator or a lift, which has dropped very suddenly. You can feel your stomach rise, and that sensation stays with you for about a day. And then the fun begins. You can fly down the length of the space station just using your fingertips. You can almost swim through the air. It's a most extraordinary feeling. It feels great.
You
would love it. You would absolutely love it.
I'm sure I would. But what about the day's routine?
Normally the day starts... You're trying to get some sleep in your sleeping bag, which is tied to a bulkhead or the ceiling. Some people sleep upside down. One person I know likes to sleep free float. He just floats around like this in the cabin. When a shuttle crew's visiting, it's pretty much an 18, 19-hour day to do all the work. So you get up at the crack of dawn, you know, dawn in Houston, that is.
Yeah.
And they play some music that one of the crew has chosen or the crew's family has chosen. And then it's pretty much straight to work. eating a food bar, drinking water, and getting on with the work immediately. Either getting ready for a spacewalk or doing a lot of transfers of stuff from shuttle to station and back. In my case, that was usually preparing for a spacewalk or repairing suits for the next spacewalk. So you're working flat out pretty well every day when a shuttle's docked. But when the shuttle's not there, the station crew have a much more moderate routine of exercise, experiments, science for a 5.5, 6 day week.
What kind of experiments?
There's a whole lot of medical experiments, of course, to look at the effect of long-term zero gravity on humans. And there's been some combustion experiments looking how combustion works in zero G, protein crystal growth, a whole range of experiments that can only be done in zero G.
What about the food, incidentally?
The food is pretty good. I found it out that I like the Russian food better. It's in cans. They have a very good lamb hot pot and jellied eels and aspic, if you like that kind of thing.
I do.
There you go. The American food, it's mainly freeze-dried, so you have to add water, heat it up. Some of it's really good. Something happens to your taste buds in space. A lot of things seem to lose their taste, and you have to zap it up a little bit with some Tabasco sauce or something spicy to make it taste good.
What are your main memories?
I think it's spacewalking every time, because when you're looking out of a window on the shuttle or on the space station, it's a beautiful view, but you're still separated from the environment. But when you're spacewalking, you're in it. You're in space. And if you just lean forward into your helmet and look through the visor, you're not aware of anything around you. It feels like you're just floating above the planet all by yourself, as if, I'm talking to you right now. You're actually in the environment.
From the space station, you've done more spacewalks than anyone, haven't you?
That's right. Right now, as we sit here, I hold the record, which is 6 spacewalks and 42 hours of spacewalking outside the space station. But I think that record will be broken in a couple of months. So this is my very brief moment of glory.
When you first went out into space on a spacewalk, was it what you expected?
No. I got a huge surprise. When we've been training in the pool, the airlock is, the right side up, and the hatch is in the floor. So when you come out, you dive head first out of the hatch, and you expect to see, in the pool, of course, see dirty concrete about 10 feet below you. But in orbit, you expect to see the Earth below you, and you think that that's going to be down, and the space station will be above you. Well, the first time I came out of the hatch, the right side up, and the hatch is in the floor. So when you come out, you dive head first out of the hatch, and you expect to see, in the pool, of course, see dirty concrete about 10 feet below you. But in orbit, you expect to see the Earth below you, and you think that that's going to be down, and the space station will be above you. Well, the first time I came out of the hatch head first, I had this very, very strong illusion that I was coming up, and the Earth was like the sky, and the station was below me, and I was coming sort of up like through the turret of a tank or something. And then the whole thing flipped upside down again, and I had this illusion of the space station and the Earth exchanging places a couple of times. And after about a minute, the illusion went away, and I was never able to get it back. I was very disoriented.
In your first spacewalk, what were you actually doing?
We were putting a huge new piece onto space station and bringing it to life. So we had to put some electrical cables to connect it all up. We had to put a camera in place. We had to put a big new antenna in place. A lot of bolting and unbolting.
Is that difficult?
It's very tiring. It's very tiring because the gloves are stiff and they resist movement. A lot of training helps, but you have to be, careful, patient to get the job done. You have to be careful because the suit weighs several hundred pounds. So when you start moving along, you're gliding along quite freely, but it takes some force to stop yourself. It's like moving on ice almost. You can just glide along, but you have inertia, so you've got to be careful. Your hands get a really good workout. You're working very hard with your hands all the time against the pressure of the suit.
How do you move around when you're spacewalking?
Fingertips. Just use your hands and crawl along the handrails. It's a great feeling. It's almost effortless to move around. And the other extraordinary thing is that you can move all around space, and up, down, over, round, underneath. It's all equally easy to do that.
If you haven't got a rail handy, is there any way you can shift around?
We're not supposed to. We're supposed to just use the rails, and we do, and use your hands to get around. Well, there's another actually, a way that is very convenient. We have the big robotic arm. It's like a 65-foot long crane. And you could put a foot platform on the end of that, jump onto the foot platform, and then talk to your friends inside, and they'll take you anywhere you want to go on the outside of space station. That's fun. It's like standing on pretty much something the size of a phone book, and you get taken around all the outside of space station. If you fall off, we have a wire that you can use to pull yourself back, and also a little jetpack that'll bring you into station very slowly. But you shouldn't be using that unless you're in real trouble.
Has that ever happened?
People have fallen off and pulled themselves back in using the wires, and we have tested the jetpack, but no one's used the jetpack in anger.
I hate to bring this up. What about the dangers? I mean, always a danger of a meteorite hit.
Well, you know what? That's not the biggest danger. Well, 60 to 70% of the risk in spaceflight is the launch.
Yes.
About 20% is the entry. So it's the first 50 miles and the last 50 miles is the most dangerous. When you're on orbit, a micrometeoroid strike is a risk.
Yes.
It's about a 1 in 200 for the shuttle on a given flight. And we've seen impacts on the station. So when I'm spacewalking, I always try and get the other guy to stand in front of me. No, I don't.
What about radiation problems?
Radiation, normally it's equivalent to about 2 chest x-rays a day. All right, so you get a fair dose of radiation, but we haven't seen any ill effects from people being up there for 6 months.
And communications, no problem at all. You're in touch the whole
Almost
time.
continuous. We have almost continuous communications. Now we have an antenna that goes to the geostationary satellites, so we have really good communications just about all the time. And TV communication quite a lot of the time. So we're much better off than previous generations of space explorers.
Yes, indeed.
We really are. In fact, when I'm outside spacewalking, I have 3 TV cameras on my helmet, so my friends on the ground can see what I'm doing. And in a couple of cases, they've told me to go back and do something that I'd forgotten or hadn't done right. I've got people who actually can see what I'm doing and help me. And that's enormously good.
When you were out in space doing your space works, were there any alarms?
Yes, I had a number of things happen that got my attention. Had a low oxygen warning in my suit. Little thing crops up and says, O2, you're down to 19 minutes. At that point, we were just getting ready to get in the airlock, so we didn't hurry, but I was motivated to get indoors fairly quickly. And just problems with working with equipment that wouldn't cooperate, but eventually you find a way around it. Get a bigger hammer.
Anything you were asked to do that you really didn't want to do?
Come back inside. I guess at the end of the spacewalk, say, hey, time to pack up, come back inside. You always want to stay out there and enjoy the view.
They've repaired the Hubble Space Telescope. You have plans to go there?
I'm afraid not. I would love to go, but the crew's already been selected, and they're getting trained right now to go to Hubble. And they've got a very, very busy time of it. They'll be basically replacing all the worn-out parts, the batteries and the gyros. And Hubble should hopefully be good for about a decade after that.
Now, we talked about the Earth from space. What about the sky from space?
The thing that really amazed me when I first went into space was how thin the atmosphere is. You look at the curve of the Earth, and there's this really thin layer of air that you can see, the blue layer of air above it. And when you look carefully, you can see that the thunderstorms go halfway up the atmosphere that you can see from space. So there's almost no atmosphere at all. It's just like a little onion skin around the planet.
How much detail can you see?
Incredible. When I flew across the Atlantic, I could see little jets pushing across the Atlantic. I couldn't see the planes, but I could see their contrails, see ship wakes, cities. Unbelievable, beautiful, beautiful detail. It's like a model. Intricate and so beautiful.
Where are the stars?
Don't see them. You know what? During the daylight, you just don't see them. The sun is so bright.
Yep.
And you're just out there spacewalking, you have a black, black sky and a brilliant white sun. Just so brilliant it hurts your eyes unless you have your visor down. At night, we have the floodlights from, the station and shuttle shining on the work site where you're working, and you also have helmet lights. So that's bright. The only way you can see the stars really is to get to a dark corner of station out of the floodlights, turn off your helmet lights and look up. I've done that. And all the stars come out, and it's just they're very steady. Of course, they don't twinkle, and it just looks like silver dust on a black cloth. It's just beautiful.
We've seen pictures of the space station in orbit, of course. Sort of, how much more would it extend?
Right now, it's about just shy of the halfway point. It'll be twice as big when it's finally finished. It'll be 500 tons, which is big.
What do you think are the most valuable results so far obtained from the space station?
Curiously enough, scientifically, there's not been much in the way of great science delivered from space station yet, and that shouldn't be a surprise. I think the greatest yield from space station up to now has been learning how to build large structures in space, how to make a survivable habitat in space that will work for a long time, and how well people stand up to living in space and working in space. It's all more difficult than it sounds. It really is a hard thing to do.
What's your forecast for the next few decades?
Well, I think what you'll be seeing is space station will go on till about 2020, and it'll be with a 6-person crew, and I expect to see a steady trickle of science and technology come down from space station. About 10 years from now, we'll have landings on the moon and construction of a small lunar base.
You say a lunar base. What do you envisage that being like?
Well, the current thinking is to have it down on the south pole of the moon, probably in Shackleton crater.
Yes.
And the reason for that is that you have some sunlight all the time when you're at the south pole of the moon, and that would be useful for powering solar arrays and keeping the temperature fairly even on the base. So the current plan is that we have these lunar landers that will go down, and every time they go down, they will leave some piece of structure and slowly start to build a lunar base.
Casting my mind back, I remember mapping that part of the moon, the crater Shackleton.
Really, what's it look like for real estate?
Well, I'd like to go there. I'll get further ahead still.
Hopefully about 15 years to 20 years from now, we'll see humans landing on Mars. And by that time, I would expect that the whole of the solar system would have been thoroughly explored by robot explorers and landers all over the solar system. The moons of Saturn and Jupiter, I would expect to see landers.
I wonder.
I think space exploration is the challenge for this generation and the next few generations. 500 years ago, Europeans had the oceans. That was the great unknown. And it didn't look like a very good prospect to explore the oceans at that time. But we did it anyway, and we have the Americas as a result, among other places. I think space exploration, we're in the very, very early stages. Space is our ocean now.
Piers, you've seen a lot, done a lot, and we've been very honoured to have you with us today. Thank you for coming and joining us.
Thank you very much, and the honour is all mine.
Piers, just down from the International Space Station. But would you like to see the space station? Well, you can. Let's go now to my observatory, where Chris is talking to Pete Rogers.
Well, we don't need a telescope like this to see the space station, but Pete, what does it look like in the sky?
Well, the ISS looks a bit like a star, to be honest. It moves across the sky fairly slowly. A typical ISS pass takes anywhere between 3 minutes and 6 minutes to cross the entire sky. So you have a bit of time to sort of locate it and to see it, basically.
How bright is it?
The brightness of the ISS changes depending on what's actually going on up there at any one time. If they have the full solar panel array open, then it's fairly bright, and that has been the case recently, and it's been quite astounding to see it. Actually, it's very impressive.
As you say, it's fairly obvious, but it does help to know where it's going to be.
That's the key, really, if you want to find the ISS. Sometimes you see it by accident, but more often than not, you actually need to have some sort of prediction to actually be able to see it. And there are websites available to help you do that. One very popular website is Heavens Above. And if you wander on there, you can enter your location details and then basically go in there, click on the ISS link, and it will give you a table of where the ISS is at any particular time.
And that gives you a time when it rises and when the pass ends, and it also gives you these altitude and azimuth numbers.
It also gives you the brightness, so you know roughly how bright it is.
And we've got your camera here, and of course you can take pictures of the ISS as well.
Yeah, you don't need a fancy camera to do this. You can do it with a point-and-shoot camera, as long as you have a reasonable exposure length on it. A few seconds is quite adequate. And if you have the prediction, you know roughly where you're looking, you stick your camera on a tripod or on a cushion or something so it's not going to move, open the shutter when you see that dot starting to move, and you'll get a line, just like this shot here, which shows you exactly what the ISS looks like when you've taken the picture.
There have been some amazing high-resolution images as well.
Here we've got a picture of the entire disk of the Sun, which actually shows the ISS moving across the full frame of the Sun. It looks like a sunspot, actually, in that full image there. And there's another dot next to it. But if you blow it up on a magnified version, you can see here we've actually got the International Space Station with all its detail and finery in there, the solar panels and the main body of it. But if you look at the dot next to it, that's actually the space shuttle. You can just make out the tail.
Oh, that flat bottom with the tail.
Yeah,
that's incredible.
That's incredible. It's a quite wonderful photograph, absolutely superb, and really puts everything in perspective.
So watch out for the International Space Station. Also in the sky, the Hubble Space Telescope, due to be maintained and serviced by the astronauts. With me, Professor Jerry Gilmore from Cambridge. Welcome, Jerry. First of all, just what are the astronauts going to do when they get to the Hubble?
Hello, Patrick. Nice to see you again. Well, this is service mission 4, so the 4th attempt to fix it, basically. It's an old telescope. It's like you and me. It's starting to fall apart. And they're going to replace all the worn-out components, the gyros, the batteries and stuff like that. But most importantly, they're going to put in 2 new state-of-the-art instruments. So they will attempt to repair one existing broken instrument, which has lost its power supply, the Space Telescope Imaging Spectrograph, and they'll put in 2 new ones, a new camera and a new spectrograph.
Can you say a bit more about these instruments?
First of all, a new camera. This is basically an upgrade for the existing famous wide-field camera, the one that takes all these gorgeous pictures that we see all the time. And this is basically just using newer detectors. And the key feature is that they will be more sensitive in the ultraviolet and they'll be more sensitive in the infrared. So we'll have a wider range of colours. The key here is that we'll be able, in the ultraviolet, to look at hot stars and young stars and galaxies as they are forming in the local universe, and then compare that with what we see in the infrared at the very high redshift universe. And so that's the real challenge, is to say, do young galaxies long ago look like young galaxies today?
And do they?
Well, we don't know. We'll have to wait for our new camera, won't we? And it's going to produce some spectacular new pictures. The other instrument is the new spectrograph, and this key here is to observe really what's between the galaxies. The galaxies, as we know, have got all the stars in them, but most of the atoms in the universe are actually between the galaxies. They're spread out in this filamentary structure called the cosmic web, sometimes, filaments and strands throughout space. And we can see this only from the way it absorbs light from background objects. So the new spectrograph, the cosmic origin spectrograph, is really designed to observe point sources, quasars, at very high redshifts indeed, but to use them as just background light sources, and to look at the way that the light from those quasars is absorbed by all little gas along the line of sight to map out all the filaments in structure. So the idea there is that to understand the large-scale structure of the universe and how the universe got to have its present foamy, lumpy shape and structure.
When is this next servicing mission going to go up?
Well, the precise date isn't known yet, but it's a while. It'll be summer, late summer probably next year, so maybe a year and a half from now.
How long do you think Hubble can be maintained now?
Well, one of the other things they're putting on Hubble this time is a guaranteed death certificate, which is kind of interesting, so we can answer that question now. They're going to add on the back of it a little hook, so that when it comes to the end of its life in about 5 years' time, just before the James Webb, with luck it'll overlap the James Webb for a year or two, so we'll have both in parallel, but in about the year 12 or 13, they'll be able to send a robot up, which will grab hold of this hook and flick the Hubble telescope into the ocean.
Is there no chance of just putting it into a higher orbit and leaving it there?
At present, it's right at the limit of what the shuttles can do, and of course there won't be any shuttles after 2012 either. They're being replaced, and so it's just part of the natural evolution of technology, in the same way that the cameras now are much, much better than they were 10 years ago, because the detectors are better.
I know, but to dump Hubble in the sea seems wrong to me somehow.
Sadly, all good things come to an end, Patrick.
I suppose you're right. Jerry, thank you very much. It's newsletter time. Therefore, if you want your newsletter, send your stamped addressed envelope to Newsletter 104, The Sky at Night, BBC, Birmingham, B1 1RF. And when I come back next month, we'll be doing a special programme about Mars. Until then, good night.